Expressing let this way in parse as a transformation into lambda plus application, that's an example of a concept called syntactic sugar. That is, we're making the syntax of the language a little sweeter, a little nicer for curly programmers to read, but transforming it in a way into other things that we already have in our language. And we could add other things to curly in this way. For example, we could add a negate form that takes any number and produces the negated form of that number. So if we parse -3, our parser could produce mult e num e minus 1. So that would be clearly equivalent to negating 3, and we don't have to change interp that way, we would only change parse. Actually, in the case of negate, we might want to just have a library that defines a negate function. Curly doesn't have libraries per se, but we could wrap a program with some lets, including one that binds neg to a function that takes in and multiplies it times n minus 1. So these are two different ways that we could extend our language. By this library approach, a syntactic sugar approach, they're both examples of encoding things. We're introducing new concepts or new features into the language by just expressing them in terms of things we already have. We've already seen some other encodings. When we looked at mutable variables versus boxes, we noted that you could implement mutable variables if you already had boxes by just changing everything to use boxes. A set bang would turn into a set box, as long as we also change all variable references to turn into unbox, and as long as we change all function calls or other bindings to when we pass an argument to the function to allocate a box to store that number. So we were able to encode mutable variables just using boxes. We also went the other way. We were able to encode boxes using mutable variables. And there we took a more library-like approach. We defined crate, uncrate, and setCrate as functions that implemented the same thing as box, unbox, and setBox, but using mutable variables instead. Actually, for setCrate, it wasn't quite the same as setBox because we only have single argument functions, so setCrate had to take the crate first and then return a function that took the argument. If we wanted to make a set crate that had two sub-expressions, then we would have to do a little bit of changes to parse to make that work. And that actually suggests there's not a clear boundary between libraries and syntactic sugar. It depends on your language. In fact, in Racket and Plait, we've seen that you can, in a library, that is through extra definitions in your program or put them in a separate module, extend the syntax of the language. When we were implementing our interpreter with stores, we wanted this with form to make the program a little more readable, and we were able to do that with defined syntax rules. So it's not so much syntactic sugar versus libraries that is the key idea here, but the idea of encodings. Not everything can be encoded. If we don't have any state at all, we don't have boxes or mutable variables, there's no localized encoding that will give us boxes or mutable variables. Of course, we saw we can write a whole interpreter, a store passing interpreter, that gives us state without using state at the plate level, but that's different than a localized encoding. Similarly, we started out with defines with just single argument functions. It turns out there was no way to get the full power of lambda with just those kinds of defines. And since we couldn't get lambda, we also couldn't encode boxes if we had define and single argument functions and variables. So different things can be encoded depending on the language that you start out with, and that's one reason that we're looking at encodings. It'll help us tease apart what are fundamentally more expressive concepts in a programming language and which things are just small variations like let on top of lambda or boxes on top of variables. Another reason, and the one that goes back to the example that we saw with let and lambda, when we discover that we can perform some encodings, perhaps we don't need to add new core forms and change interp. Perhaps we just change parse. And we're going to look at a number of different things that we could conceivably encode as opposed to building it into our language. In practice, the encodings might be complicated or they might perform badly, so we won't actually perform many of the things we'll look at as a change to parse in Plait. Sometimes it'll be things we just do by hand, and sometimes it'll just be ideas that we'll say it's good to know that that could be encoded, and then we'll go focus on other things.